Okay, so we're moving on to the second topic in our discussion about polynomials. In this video, we're going to talk about how to add and subtract polynomials. As far as learning objectives, that's it. Our simple learning objective is to add and subtract polynomials. That's all we've got. So adding is by far the easier of the two. Actually, they're both pretty easy once you get used to sort of a trick that I'm going to show you with subtracting. Trick is the wrong word, but you'll see when we get there. Adding, however, is basically exactly the same as what we talked about in the last video. So here's an example problem. The first thing I want you to recognize is the directions. Add the polynomials, and the directions, I cannot think of an exception. I think it's pretty much always going to say this. The directions say write your answer in standard form, okay? So you should just assume that you're going to always have to do that. Like I said, I really can't think of an exception. So we're going to add the polynomials and write the answer in standard form. So here's what I want you to notice though. This set of parentheses that marks polynomial number 1. There's no number on the outside of the polynomial that I need to distribute. It's simply being added, so it's not like I need to multiply it by something else. These parentheses don't mean multiply. There's no exponent on the outside, so the parentheses don't tell me that I need to raise something to a power. All these parentheses are doing is grouping together these terms so that I know that these terms form a single polynomial. In the same way, these parentheses are just simply marking off where this polynomial starts and stops. But the parentheses themselves really are not doing anything as far as mathematically significant. They're just showing where the polynomials start and stop. And since everything is all plus signs, I can completely ignore the parentheses. And so I can treat this problem as if it was just what we looked at in the last video, where I have got one great big long polynomial, and I'm just going to simply combine like terms and then put them in order for standard form. So when we talk about adding polynomials, it really is just that simple. Ignore the parentheses and then put it in standard form. So standard form means completely simplify it. So I'm going to combine like terms, x to the 4th, that's my biggest. So I'm going to do that one first. There are no other x to the 4th, so this whole term, that's going to go first. Now I've got an x to the 3rd over here. There's no other x to the 3rds, so this whole term will go next. Okay, I do have an x to the squared here and x to the squared. That's not the way you say that. I've got an x squared and another x squared. Those two things will go together. This term is a plus 1x squared. Remember, I've got that sneaky ninja hiding there. This term is a minus 4x squared. So if I do 1 minus 4, I'm going to end up with a negative 3x squared. Okay, now I move on to just my plain old x's. So I've got a plus 7x here, and I've got plus 1 more x there. 7 plus 1 gives me a total of 8 x's altogether. And then last but not least, a negative 3 and a positive 5. Negative 3 plus 5 equals positive 2. And so there's my answer to the first example. Okay, so all I'm doing when I'm adding is functionally ignoring the parentheses and then putting it in standard form. Here's one more addition problem. Now I've got 3 polynomials being added together, but again, same thing. None of these parentheses are doing anything other than showing me where one polynomial starts and the next one stops. That's all it's showing me. So I can ignore those parentheses. So why don't you pause the video and try this one on your own. Once you've got it done, then resume the video and see if what you did matches what I did. Okay, so hopefully you finished this. And the first thing you should have done is just ignore the parentheses. For the sake of time, I'm not going to rewrite it. I'm just going to say, hey, we're ignoring these. Okay, so just for the sake of time to make the video go a little faster, let's just ignore the parentheses. So I have squares for my largest exponents. Those are my largest exponents. I've got a 3x squared, I've got a negative 7x squared, and I've got a 1x squared. So my x squared term is going to come first, For my coefficient, I have 3 minus 7. 3 minus 7 would equal -4. And then -4 plus 1. Notice, just like regular old operations, I'm just doing them in order from left to right. That's all I'm doing. So 3 minus 7 is -4. -4 plus 1 is -3. So there's my first term, -3x squared. Now I move on to my x's. So there's my x's. I've got a positive 1x minus 5x. So that's going to be -4x. And then plus 3x. So -4x plus 3x is going to give me a -1x. And I'm just going to make that one be a ninja. Last but not least, my constants, just going in order from left to right. -5 plus 2 is going to equal -3. And then -3 plus 1 is going to equal -2. And so there's my answer for this problem. Okay, so that's adding. Functionally, we're just ignoring the parentheses, and then we're moving on by combining like terms in order from left to right. Okay, subtracting. So I mentioned at the beginning of the video that subtracting is very similar to adding. It's fairly straightforward, but there's a little trick or a secret to it that I have found. And the reason for the trick or the secret is, after years of experience, both of myself as a mathematician, myself making this mistake, but also as a math teacher watching students do these problems, I see student after student after student making the same mistake. So what I'm going to show you right now is not something that's, mathematically profound. It simply is a way to avoid mistakes, okay? It's not an absolutely mathematically required step, but I have found that the students who take this step tend to get more right answers than the students who don't, okay? So here is my trick, and you might even jot this in the margin of your notes if you want to. I'm going to treat this negative sign as if I'm adding a negative, okay? We know from elementary school or middle school, I guess I don't remember where they teach this, but from somewhere in our past, we know that subtracting is the same as adding a negative. So I'm going to think of it that way. So that's the first mental shift that I'm going to make. But now I'm going to make one more mental shift. I'm going to think of this as being a -1 times this polynomial. So functionally what I've done is I've changed the minus sign into plus -1 times. Okay, so now, in fact, I'm going to go ahead and actually write that. Plus a -1 times my polynomial. So, and I haven't done anything to the first parentheses. So for just a second, I'm going to kind of ignore the first parentheses for just a second. And just ask you to think about this expression right here. If somebody asked you to simplify that expression, what would you do? Well, you would distribute the -1. So that's exactly what I'm going to do in this problem. I'm going to distribute this -1 to all the terms in the parentheses. This other polynomial that's hanging out in the front, it's just still there. I'm not doing anything to that yet. Okay, so my little trick, my little tip, my helpful hint, my strong recommendation, whatever you want to call this, is change the minus sign into plus -1 and then distribute that. So what I'm going to end up with after I distribute is a plus problem, an addition problem. And like we just said, oops, I just wrote that wrong. Like we just said a second ago, addition problems, I'm just going to ignore the parentheses. So when I distribute that -1, I'm just going to ignore all the parentheses and write what I get. So -1 times a -2x is going to give me, I'm sorry, -1 times positive 2x is going to give me a -2x cubed. -1 times a -4x squared is going to give me a positive 4x squared. -1 times positive x is going to give me a -x. And -1 times positive 5 is going to give me a -5. And now I just combine together my like terms. So I've got only the one term that has an x to the 4th. So there's nothing for it to combine with. I have one term that has a x cubed. So there's nothing for it to combine with. I have two x squared terms. So a positive x squared plus a positive 4x squared is going to give me 5x squareds altogether. Here I've got a 7x, and here I've got a minus x. So 7 minus 1 is going to give me 6x's. And then lastly, my constants, I have a -3 and a -5. -3 minus 5 will be a -8. And there's my answer. Okay, so my little helpful hint, again, you might want to jot this in the margin, highlight it, something, make sure that you see this so that when you're looking at your notes later, you don't forget. Helpful hint, turn the minus sign into plus a -1 and then distribute the -1. Okay, so here's another example. Why don't you pause the video and give this one a try? All right, so hopefully you've already tried this, but I'm going to do this exactly the same way as I did the last problem. The first thing that I'm going to do is I'm going to change the minus sign into plus -1, and then I'm going to distribute that -1. Once I distribute the -1, this becomes an addition problem, so I can ignore the parentheses at that point. So now I'm just going to write down what I get after I distribute the -1. The first thing doesn't change, I just ignore the parentheses. -1 times -7 gives me a positive 7x squared. -1 times positive 5 gives me a negative 5x. And -1 times positive 2 gives me a -2. Now from here, I'm going to start with my biggest exponent and work my way down, combining like terms and putting things in order at the same time. So my biggest exponents are my x squareds. 3x squared plus 7x squared gives me a 10x squared. Next, I've got my x's. So I've got a positive x and a negative 5x. When I combine those together, that's going to give me negative 4x's altogether. And then lastly, the constants, a -5 and a -2 will combine to give me a -7. And so there's the answer that I got. Hopefully you tried that one on your own and came up with the same answer. I want to just say one last time as we close out the video that this little tip of changing into plus a -1 and then distributing the -1, it is absolutely possible to do these problems without doing that. But I just want to say one more time that after years and years of experience and practice and watching people do these problems and doing them myself, I know that the people who don't do this, but instead just insist on subtracting all the way down, those people tend to make mistakes where the people who distribute the -1s don't. Now, that's not to say that the distributing -1 people are always perfect and they never get it wrong. That's not the case. It's just that people who choose to subtract without doing this tend to make a certain kind of mistake much more frequently than what these types of people tend to make. Okay, so it's just my strong recommendation that you do it this way. If you're going to ignore me, you have that right. Feel free to do so. But this is the way that I will be doing the problems. All right, so thanks for watching this video. Make sure you do the homework problems associated with this topic. And that's it for now. Have a good one.